What's up everybody? Welcome back to Make It Custom. I'm Carl Fisher and today we are going to build a power hammer from scratch, from scrap metal without using the machining tools. So I'm just going to use a drill press, a grinder, a torch, basic stuff, and we're going to build this power hammer from scratch right now. You guys can do it too. Let's get into it. Don't forget to like, click subscribe, hit notifications. Let's do it. All right, so this is gonna be a little bit of a different video than we're normally used to here. Something that I've been thinking about for a while, and after being down in the States, kind of doing the classes with Christian and just kind of talking to him about metal shaping and machinery and that kind of stuff. Like he makes the power hammers and I make the planishing hammers. I wanna get into making other machines as well. Like I've got kind of a bunch of ideas for them. But we were just talking about, like how simple it could really be if you needed to be. Like it's just a hammer. It's just a motion, like if you break it down into movements and try and figure it out, you might be able to just build one yourself for really, really cheap. So yeah, we were talking, he's like, you know what, you could just start with two hammers, like two little mini sledgehammers, and just build off of that and make them do this kind of motion or whatever. And I've researched a bunch of different designs on power hammers. Like his is like the Helve style hammer. There's like the Pettingill style hammers. There's like the, there's like fixed stroke reciprocating hammers. There's, like sprung stroke reciprocating hammers. There's all kinds of hammers, and basically they all at some point just have to have enough power and come together to be able to move metal. And in some cases you want there to be spring, in some cases you don't want there to be spring. There's advantages and disadvantages to all that kind of stuff. So anyway, I want to just kind of break it down, make it simple, see if I can't make a power hammer out of some basic stuff. Like I'm gonna try and keep it under $100. Like I had this idea and I just hopped on Marketplace, instantly found a clutch driven 1/2 horsepower sewing machine motor for like $25. And there was like 3 on there for like between 25, 30 and $35. So like, I feel like they're common enough. This is what it is. It isn't super powerful. Like it's only a 1/2 horsepower. So the design might have to accommodate for the lesser power of a motor like this. But I just wanted to start with something like, see if we can use parts that are like really cheap and like super easy to find. The other thing that I had kicking around, and at least they're common enough, anybody can get these. These are like the world's cheapest flange bearings. I think they're like $10 each. Super common, they're just like 1 inch. I had a chunk of 1 inch shaft laying around. Like I've got some scrap pieces kicking around. I do have a pulley that's, luckily 1 inch shaft. I was kind of looking around to see what I have, but these are all easily attainable items like pulleys and this kind of stuff. Like you can go to Harbor Freight probably and pick stuff like that up. I'm gonna go through and see what kind of junk I've got in the scrap table, and I'm gonna try and not, oh man, it's so bright. Oh God, go away. I'm gonna try and not have to go out and buy anything. Like I really don't want to drive anywhere. This is gonna be like a creative project where I just try and like figure it out. And so since Christian and I were talking about that kind of stuff, he was also telling me stories about how he would have like little bets with guys about like making a machine and like trying to do it, fast and for no money kind of thing. And so this, I'm gonna challenge Christian Sosa right here. This is my challenge to you, Christian Sosa, Sosa Metalworks YouTube channel. I think that we should try and do this and like maybe get more people into it. I think it'd be kind of something cool. But I want you to build a hammer out of, he builds hammers, so I know you got stuff, but try and make a cheap, simple hammer out of stuff that you got kicking around. I'm gonna do the same. I went on Marketplace, got the motor. I've got some other junk kicking around. Like there's no rules to this, like whatever you want to do, but let's build hammers from crap we got and do some metal shaping, show people that it's not that hard, and that with some, you know, ingenuity, you could probably do it yourself as well. And if not, buy the planishing hammer or the the Sosa Metalworks Shape-O-Matic builder's kit or full machine. So anyway, I'm gonna get started. I'm just gonna look around at the junk I've got kicking around underneath this table. I'm gonna pull everything out. I'm gonna lay it all on the table. I've got some scrap steel that that a buddy gave to me. He's like, I got some heavy steel, so I've got junk. So I'm gonna bring all this junk out and I'm just gonna start figuring it out, okay? All right, let's do it. Okay, so I'm actually pretty happy with some of the stuff that I found. I knew I had these big beefy pieces that my friend Brett gave to me instead of going to scrap. This is just 4x6 by, I think it's either 1/4 or 3/16 wall. Pretty much what I built my English wheel with. So I know that's going to be strong. The other thing that's kind of cool is it's already got holes in it, which I think I can actually utilize. Anytime I can, you know, make something like that skip me ahead, I'm going to do it. Also got lucky finding some pipe that slips inside of each other. Like this piece, I know I was using it as like a pick to like bust up my driveway to put cable in, but it's a nice thick piece of pipe and it slips inside this one or this one. So we've got something where we can have maybe a bit of grease in here. Like I'm definitely not going to have bushings for everything, so things are going to be steel on steel, but this is DOM tube, this is DOM tube. They slip nice inside each other. They have a little bit of play, but I think it's gonna be fine. And then I've got another tube that also slips inside of this one, which I believe is just, this is 1-inch ID, so that we could use this type of a material as our dies. That's kind of what I'm thinking. So this actually coincides with the size hole this is. So if I were to cut these pieces as little sleeves that went through here to here on the inside, like put them in here, then I wouldn't actually even have to drill these holes, which would be really nice. So I'm gonna cut a couple pieces of these, and this will be my lower tool post, and that will be my upper. This one will have to come through and then have some kind of reciprocating motion on top of it. Like we haven't figured this out yet, but for starters, I'm just gonna build a C-frame, and then I'm gonna use this material, cut it to size, put it inside here so that there's a tube going right through that, and then I'll figure out kind of what I'm going to do as long as I have enough material to use this as the actual reciprocating motion deal. I don't know. That's where I'm going to start though. I'm going to make the C and then the tool holders.
Perfect.
right, we're moving right along. I do love the way this worked out. I'll be able to weld these thicker pieces of pipe in here. This will be my sliding lower tool holder. I'll have to figure out a way to adjust that up and down, maybe with a thick bolt. But that'll be that. Maybe I'll cross drill it, kind of like the Shape-O-Matic dies, so that they can lock in there. This will be the upper. This one goes straight through. And like I said, I'm just gonna grease the crap out of this stuff. Like, it's just steel on steel. You know, this is, let's be honest. You know, if you're gonna be a hobbyist and you're gonna use this thing, you could probably make this machine and not worry about all the little details of making a machine that will last 100 years and just make it with what you've got. It'll probably do what you need it to do. I mean, that's just the truth. You know, if you're a hobbyist, you don't need crazy, crazy stuff. So I'm gonna show you. I think it's gonna work. I hope it's gonna work. As long as that motor is powerful enough. It's only a 1/2 horsepower. I know that the Sosa Shape-O-Matic power hammer is like 2 horsepower. So I'm hoping that the linkage that I've got in my brain, it's very similar to a Pullmax, how they work. This linkage will hopefully make it so that this little motor is powerful enough. I hope. And I only have, you know, the pulleys that I have. I could go to a larger pulley or change some kind of mechanical advantage in the machine later on if it's not strong enough. But for now, I'm just gonna see if I can do it with what I've got. So right now, that's that. I'm gonna leave that. I know this is gonna work out somehow. The compressor just went on. Take 2. So the compressor shut off, thankfully. And so my next step right now is to figure out a way to reciprocate this up and down. How am I gonna do that? I'm gonna do some kind of a shackle type linkage. I'm gonna try and draw it for you guys so you see what's going on in my head. It's very similar. It's so funny. I had seen this on somebody's homemade machine before. I had not seen inside of a Pullmax. But my friend Louis, also in Vegas, an incredible artist, he just bought a Pullmax from our friend Jeff, and he showed me the inside of a Pullmax, and it's basically exactly this. So I'm going to show you. What it is we are going to have, this is, we'll call this our crank that has an offset. So this will be, we'll have a connecting rod going to a fixed point here that is shackled. And then our point here, this will be the tube inside of the frame, and it'll have our tube inside of it that we want to go up and down. So this will be shackled to here. Okay, so now this will be an in and out motion because of the eccentric on the crankshaft. It will push this in until these are vertically aligned, which will then push this down. Okay? Hopefully that makes sense to you guys. That is the kind of linkage I'm going to build for this style hammer. I think it's going to be very simple. I'm going to use very thick flat bar. I've found this like 3/4 inch thick flat bar. It's got a piece welded to it from an old die, but I'm going to drill some holes in this. Will be our shackle. I'm going to call them shackles. This will be a fixed point. So I'll have to have some kind of way of attaching this to the frame itself, so that it is strong. So maybe our frame is coming out like this, you know. I guess it would look like that. So yeah, some way of attaching this fixed point to the frame. This crankshaft will be on those bearings I'm talking about, so I'll have to build a bracket that holds on to those bearings. We'll have to build a crankshaft, which I'm thinking will be this piece of scrap I found. I'll just drill a hole offset that's 1 inch. We'll use a 1-inch pin going through that. That will create our oblong, and then have some kind of piece of steel that goes around this. Again, it'll probably just be with grease because I don't have the bushings, and that will be our connecting rod to the shackles, which will be this flat bar. This works in my head. I don't know if it works in real life. Also, we'll have to have a pulley on this crankshaft going to the motor. The fingers crossed $25 Facebook Marketplace industrial sewing machine motor with clutch, a VEC clutch. Even has a little bit of a pulley on there for us already. So yeah, that is the plan. I'm just gonna get to it. Let's see if it works. All right, update time. Where are we at? So we have made, these are 1/2 inch thick by 2 inch wide flat bar. I did find a big rusty piece, and that's what I'm making my shackles out of. That is, if you remember the drawing, that is this stuff. Those are those 3 pieces. They will attach, see I have an well, how crazy do I want to get? Let's just go over what I've got already. So there's those 3 pieces for the shackle. This will, one of these tabs, there's 2 here. I weld them together so that I can drill them at the same time. It's just more efficient. So one of these is actually going to weld onto the top of this bar. See, this is our reciprocating upper bar. So one of these will weld to here, and that will then pin to the double shackle of this drawing. So like I said, that one piece will be here, and we're looking at it upside down. Let's not confuse anybody. Okay, let's go here. This is already confusing enough, but it's very simple. Okay, so one of these will be on top of here. One of these will be like this. One of these will, or 2 of these will be like this. And that will be our shackle. They will all be pinned. This one here at the top is a fixed location, so that when this pushes down, or sorry, pushes over, we haven't made this link yet, but when this one pushes these shackles over, it will push this down. That's what's going to get our reciprocating motion, is this eccentric, which is this. I just drilled a hole offset in a piece of solid, and so that will basically ride inside of another piece of tube that will be attached to this rod. So this will be our connecting rod, so to speak. So as that does this, it will push this in and out, which will make this then go up and down. The beautiful thing about that is that when this is pushed this way and this is straight, the amount of force that it takes to go like this versus the amount of force that you're getting down. I'm not an engineer, but I know that it's easier for it to push this way. It's like a mechanical advantage that it's getting. So hopefully that style of mechanism will lend well to our underpowered motor, or maybe it is got enough power. I really don't know. I'm just guessing on all this stuff and kind of trying to see it work in my head, trying to use simple tools. I'm trying not to use the lathe. I'm trying to use things that you can buy as metal, you know what I mean? Like DOM tubing is something that doesn't have the ridge on the inside of the tube, so you can slide it over something solid. There's like a little bit of built-in play there, just in the way it's manufactured, so it'll have enough room for a little bit of oil or a little bit of grease. I'm gonna drill some strategic holes in some of those link bars so that we can use like a little needle oil dropper and kind of drop. It will help the life of this stuff. If things are dry and they're galling, that's what destroys things. But if you came to this machine every day, you used it, and put a little drop of oil in every little joint, it probably is gonna last like quite a while. So we're gonna test that out. We're gonna find out, can I build a power hammer in a day that lasts more than a day? So that's where I'm at. I'm going to now, I think, I found this chunk of metal. It was funny, we were out, quick story. If you guys have seen Sam in here, she has this hearse. We were out one night, it was on Halloween, going around like checking out people's haunted houses, and I picked up this heavy chunk of like manhole cover just because it was an interesting shape and it was a heavy chunk of steel. And then I was making a fire pit for a buddy and cut this out of a rim. So I'm thinking this could be the base. This is like pretty thick stuff. This could be the base to the hammer, and this could maybe add some weight. Ouch. To the base. And then this is just a chunk of metal I had laying around. I'm not gonna bolt it on, but we could actually just weld it, stitch weld it on, and then go from that to maybe some 4x6 tubing straight up to our C channel that we are fabricating here. I'm just using stuff I got laying around. I think it's so awesome when you can actually like utilize stuff that you have and come up with something that works, because you know, it's just a bunch of junk that you didn't really care about anyway. So I encourage you guys to like think about this. Like, I don't know if this is gonna work for sure, but I know people that have made similar machines that do work. So just give it a try. Like if you got a bunch of junk laying around, get it in your head how you can make a mechanical movement that reciprocates or springs and whips like a hammer. And I mean, after that, it's designing dies that will work, which we're gonna get into as well. You can just make your own thumbnail shrinking dies. I'm gonna do that for this machine right here. Christian, get on it, buddy. I wanna see you make a video of you making a hammer with a bunch of junk. I wanna see it. I know you've done it before. Let's see it on YouTube. All right, I'm back at it. I'm gonna build this frame. I'm gonna weld that stuff up, kind of make the hammer look like a hammer, and then we're gonna really focus on the linkage and getting that dialed in, mounting bearings, that sort of thing. All right, bear with me. I'm gonna try and explain where we're at. So, this is our little cam setup. This is just that solid piece of 1.5" round bar that I drilled offset for a 1" shaft. Couple of very cheap flange bearings. This gives us our cam, which just kind of like pushes this back and forth a little bit. This will have these 2 pieces welded onto it to make it our connecting rod, right? So this is essentially going to go in and out, in and out. That is going to then be connected to this piece that goes. This piece will then be coupled like these to these. Like I was saying before, fixed position at the top, which will be welded in here with these bungs. This, when actuated in and out, will push this up and down, hopefully. Now the things that I do not know, because I was sort of forced to use these measurements based on the material that I had and the options that are within these walls. I'm a little bit concerned that there may not be enough of a cam or of the crank distance. So I think this thing only moves about 1/2 inch in and out. That might not be enough movement to get this up and down enough. I don't think it needs to be a lot, but these are things I do not know. I did drive by Princess Auto today, and I did go get a different pulley. This was the pulley that I've been showing so far. This came from Princess Auto as well, just a cheap pulley. But I got a bigger one because I just know that it will be stronger this way. Meaning not stronger, but it will have more power than having this small pulley on here. And I think that we need every bit of power we can get with that inexpensive marketplace motor. So yeah, I blew an extra 35 bucks on this pulley. I think it's necessary. Obviously, if I wanted to, I could junkyard this stuff, but I'm just trying to make this thing happen right now. So the tally is still like around 100 bucks minus whatever material I had laying around the shop. So like, you should be, if this works, you guys should be able to do it too, and it shouldn't cost you too much money. I'm trying not to use, I'm so tempted to use the lathe and the milling machine, but I'm trying not to, so that you know, guys can just figure it out. Like I'm gonna have to figure it out. But anyway, let's keep going. I'm gonna do a little bit more carving out of this so that we can get our pins through. I was just kind of like mocking it up in there, and I do need to trim away a little bit more. So I'm gonna trim away a bit on that, and then I'm going to clean this up. We're gonna start mounting things. We're gonna make these pins a little bit more secure. I don't know if I'm just gonna use the cotter pin in a washer or what I'm gonna do, but assemble this linkage, get this piece welded on so that this connecting rod is done, tighten everything up, have a look at it on here, and then we're also going to talk about what I'm going to do for dies, being that will be next. Oh, hey Roscoe, just stop raining out there? Hey? Oh yeah. I'm actually like pretty excited right now, you know? It's crazy what you can just do with chunks of steel and bearings and stuff. Maybe I should have been a millwright, I don't know. Check it out. So you turn the wheel, check out my linkage here, in and out, makes her go up and down. So it doesn't move a lot up and down, and I don't need it to move a lot up and down. Like, you know, using the Pullmax at Christian's place, the stroke is very, very small. There's 2 stroke settings on his Pullmax because there's an eccentric at the top here that allows it to have 2 different strokes. I don't have that in there, but it's pretty much moves the same amount as his Pullmax. So as long as the motor is powerful enough to operate this, which I'm pretty sure, I'm just fingers crossed it should be. I know this larger pulley is going to definitely help it do its thing. And the other cool thing about this motor is that it's got this clutch. So the motor actually spins right up and has like a flywheel, I think, in it, like a heavy rotating mass. And then you can just kind of like hit this clutch and it kind of grabs at a higher RPM. I don't know if that's going to help us. Maybe, I don't know. But the pins were very easy. I just used like pins that you can buy. I had some here, but I know that you can just get them at any hydraulic store. They're just 1-inch pins. I cut them in half and then just like welded a little stopper on the one side. Like everything is like just dead easy, dirt simple, you know, like I'm trying to make it so that, yeah, so that anybody can make this machine. Hopefully this all works. Like I honestly think that for how little of movement there is, it's gotta be pretty dang powerful, you know, having just a small amount of cam lobe in it for, you know, that small bit of movement with large diameter pulley. And, you know, if it had a longer stroke, it would take more power to actuate the longer stroke in my, you know, Google engineering degree, which doesn't say much, but I think this should work. So I'm just excited. I'm gonna keep going. The tool holder, I've got an idea for the tool post and the tool holder and stuff, but right now I'm just gonna finish mounting the motor and getting this welded up and solid at the top so that the movement is done. And once you can turn it on and the movement is done, I will move on to making the tool holders. And I'm probably even gonna make my own set of, like, I'm just gonna make my own shrinking dies from scratch. Something else I learned at Christian's is like his first set of shrinking dies was literally made from a bolt. Like you don't have to have special stuff to do this. So that's the whole purpose of this. Build something out of junk that actually moves metal for cheap. So Christian, I want you to do this too. I know you're a busy guy, but I think this would be a cool YouTube video for your channel is if you kind of participated and made some kind of weird machine. Maybe make it simpler than this. I was trying to be simple, but I know it got weird. But build some kind of hammer. All right, this is kind of a pinnacle moment. I've got a cord just kind of rigged up here. We're gonna see if this thing actually works. I've got the motor mounted with a couple of tabs. No, I didn't use my CNC. Those were some extra pieces I found that I welded some little washers in there and drilled to the right size. I'm, like I said, not trying to use the CNC. Okay, here we go. So if I plug it in, this is just gonna turn on. There's no switch. So right now that's the motor spooling up. That motor's at full speed. This is a clutch. Oh. I mean, it sounds like it works pretty good. I don't know. Okay, check out the movement we're getting. Right here. You can't really see it that well. Maybe you can. It's tough because the whole thing's moving, but I can just feather it and go slow, or I can just kind of like let it rip. Here's that linkage working. Not sure how this mechanical linkage, this clutch system is gonna work for us, but so far it seems like it's kind of awesome that it's there. And this motor definitely has like a heavy weight in it that keeps it spinning, because watch, when I undo this, that motor, like this, the motor's off right now. Still has enough torque from whatever flywheel is in this motor to run the machine. It's off. It's a 1/2 horsepower motor, so with the mechanics that are built into this, I think it's gonna be enough. I mean, it woke right up. It was like, wah, like right now. So it didn't seem like it was hurting the motor at all. So so far, we might be okay. This thing might work. So I'm gonna keep going. That dead simple motor mount, that's done. I am gonna do something to keep this like tensioned. I might use one of the extra levers from like the 2 Heim joints and a little adjuster from some of the old planishing hammers. I think I have one that I could put there as an adjuster. Just put a bolt somewhere and make it go to this, and that could be our belt tensioner. What else? What else can I do? Well, I can weld these up now that we know that this is all working. And then next, I guess, is the adjuster and the dies. So I've got to make an adjuster so that lower tool holder can move up and down. And then I need to make, I think I'm going to cross pin so that I can pin in dies that need to be indexed. You know, if you're using a flat die on the top and a round one on the bottom, those dies can swivel and it doesn't matter. But if we're using a thumbnail die, it needs to align to the top. Or if we were to make, say, like a linear stretch die, it's gonna have to align. So we're gonna need a couple of pins put through our tool holder so that we can do that. Yeah, that's next. Whew. This thing's sweet. If it did nothing else but just like does what it does, I mean, I'd be happy. All right, this thing actually works. Like this hammer, I think, I mean, the true test is going to be once we put thumbnail shrinking dies on it, but my worries of this motor not being powerful enough, I think we made a couple of smart choices during the build by going to this larger wheel. I know that that amplifies the power of it just by having this ratio, like a smaller wheel to bigger wheel. However many times larger this is kind of however many times more powerful it is. It also slows the RPM by that many times as well. This is a 3,450 RPM motor. You know, if this is, I don't know, what would you call that? Maybe a 2.5 inch wheel. This one, that's 2.5 inches times 3.14 would give us the circumference of that would, I don't know, 7-ish, you know, something like that, 7-ish. This is a, I believe, 8.5 inch wheel times 3.14, I don't know, maybe 28 or something. So we're roughly, this is 4 times smaller than this, which would make our RPM 3450 is what it starts at. Then this would be what? 1725 divided by 2 is 800 and some odd, 870 something? I don't know. Anyway, our RPM is less than 1,000 RPM and about 4 times the power when it gets to the crank. So I guess this would be acting as sort of a 2 horsepower motor that only does 800 and something RPM, 900 RPM, ish. I don't know if that's totally making sense. You guys are gonna correct me in the comments, but that's kind of what I'm thinking. Also, the fact that this cam is only moving 1/2 inch each way, right? We're not, if that was a larger stroke, it would have a harder time doing it. So that, I think, is why we're winning with the power right now. But super stoked, that motor works. I'm gonna fire it up for you guys right now. Let's check it out. Okay, when I plug this in, motor is on, just like a sewing machine. Okay, right now the motor is spooling up. When I say spooling up, I mean spooling up. It has a weighted flywheel within that motor. And the reason why I know that is because, check this out. Like right now it's on, right? You can hear it, it's on. If I unplug it, the motor's off, but it's still spinning like pretty good. So if I activate the clutch, like the motor's still spinning and it's off. So it's got a flywheel in there. I think that's also helping us by allowing it to spool up and then having a mechanical clutch. Definitely is doing stuff. Okay, we're gonna fire it up one more time here. And I'm just gonna show you guys the dies right now. I just have planishing hammer dies in it. I've got a flat one on the top and I've got a number 3 radius on the bottom. I had some leftover die holders from making the planishing hammer, so I use those parts. So right now it accepts CP dies. But yeah, let's just have a look at like some of the stuff I did, I guess. I just jammed a bolt in here and cut a slot. Like I welded this tube to a piece of tube that was clamped into my saw, and I cut this slot, drilled a hole in the end. I just drilled and tapped and jammed a bolt. This is keeping this from turning side to side. You see how I can't turn that? That's gonna help keep our dies aligned as well. So this is just a ready rod, piece of 3/4 inch coarse thread ready rod. I just welded a nut to the bottom of this tube. This is our adjuster to go up and down. Actually, like, pretty stoked the way that works. It doesn't have anything special. It's just DOM tube sliding inside a DOM tube. This is tubing you can buy. So that's 1.5 inches. And then this is 2 inch 240 wall DOM. What that means is 2 inch OD with 240 wall thickness. Notice it's not 250 wall thickness. It gives you 20 thou play to slip another tube inside that. That's why I like using DOM. That's why I was so lucky I had it here. So this tube slips inside that. Same thing up here, slips inside this. Very common sizes. The flat bar in here is all just 2 inch by 1/2 inch. All these linkage points are 2 inch by 1/2 inch with 1 inch pins. Easy stuff to get. You know, the pins, they can be a little bit sloppy. They don't have to be crazy machined. Like the vertical slop that I have, the less of that, the better, I think. But mine's a little sloppy. It's gonna work fine. Anyway, motor's on right now. The mechanical clutch arm is right here. The other thing it has is a brake. It actually has a little friction brake that stops this so that the movement of the machine stops. It's such a great motor. Like, I've talked to people that have used this motor in their trying to make a power hammer and it not being powerful enough. And that all comes down to the engineering of the linkage that it uses. How much power does it need to do it? Like, because we're only going up and down like maybe 3/16 of an inch. All that power can be, you know, put into only moving this far. If you had to move this far, depending on the linkage, I mean, it could take more or less power. Anyway, hopefully what I'm making makes sense. I'm by no means an engineer. I, you know, did not go to school for any of that stuff. I just think about things and I I look at machines and I'm interested in mechanical movements, that kind of stuff. So I think it's working awesome. So let me show you a little tester piece. I actually jammed this in here. I don't know if I filmed it or not, or if I lost the footage, but like I said, number 3 radius die on the bottom means nothing. It's just got a crown, flat die on the top, and yeah. So I'm just going to show you that it's doming this piece of metal. It is stretching it, and yeah. Anyway, check it out. A little bit. Okay, anyway, yeah, it's definitely moving metal, like quite a bit. So check this out. Look at the dome that it has put in here. This is just a little bit of time on there. Like, we've got quite a convexity happening in this, you know, it's got quite a bit of power. So I am very hopefully optimistic on making some thumbnail shrinking dies for this machine. That will be next. I'm gonna end the video here. Let me just shut this machine down so I'm not talking over it. It's really not that loud, but it's just a hum, an annoying hum. Like I said, I just unplugged it. Machine's still going. And, okay, there it is, stopped. I hope you guys really enjoyed this video. I love making tools. I love it. I love making machines. I love thinking about making machines. I love, you know, putting them together with parts that I find. This thing is just too cool. I'm gonna make thumbnail shrinking dies on the next video. I'm gonna add a foot pedal so that it's easier controlled. I'm also going to do some profile dies to show you guys that it could do like a bead roll, or not a bead roll, but like a body line. Like, what did I do on the Zephyr? Or sorry, what I did on the Zephyr, this body line that I made in the body line that I made in the bead roller, making custom dies, this machine could do it too. This is a fixed stroke hammer. This is the same style machine as what a Pullmax is, just smaller. Okay, so it's stout. It's I believe from the center of this, which is 2 inches in from the end, we've got a 16-inch throat. This is 4x6 rectangle tube, 1/4-inch wall. This is an 8-inch wheel. This is just a basic sewing machine motor. Like, all this stuff, I'm sure you guys can do this too. This is, you know, no milling machine used. You might want to use a lathe, and like, the more time you spend coming up with good dies or a way to interchange your dies, like, that's also something I'm going to do on the next video, is make it so that they're you can locate them. I've got some ideas on that could be simple, but anyway, hopefully you guys, if you're interested in making a machine, making a power hammer, making your own tools, you can do it. It's, you know, I've just made this machine in 2 evenings. You know, I made that English wheel out of a Harbor Freight English wheel. I just used the dies from a Harbor Freight English wheel. I added a steering wheel to it. This is 4x6 tubing as well. You know, like, you can make this stuff. If you want a bead roller, you want a big beefy bead roller for less money than you'll ever spend buying one, you can build this one. This one, I put all the plans, Elio and I designed this thing. All the plans are for free download on japhandskustoms.com. Like, don't be scared of getting into metal shaping. It's so much fun. So don't forget to like, click subscribe, hit notifications. I appreciate every single one of you. I love reading the comments. I love hearing you guys' ideas. Guys and girls, there's, you know, both you, everybody's on this channel, and it's an amazing community. So thank you so much. Also check out Christian Sosa's, Sosa Metalworks YouTube. I'll put the link in the description there. This is a challenge to him. I'm challenging you, buddy. You know, I don't know how much time you got or when you can make this happen, but I want to see your next YouTube video, you building some kind of machine, you know, whatever it is. Just build something and then pick somebody else to perpetuate this building challenge, I guess. All right? Thanks a lot, everybody. We'll catch you on the next one. It's gonna be a lot of fun. Cheers. Sit, 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 sit. Good girl, stay, 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 stay right there. No, 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 no.